This is a video lesson on the greatest integer function and its parameters. Generally, a greatest integer function looks like this. It has parameters a, b, h, and k. And in this video, I'll show you what each one does to the appearance of the graph, and I'll show you a few examples of how to graph a greatest integer function given its rule. So first up, h and k represent starting point of the function. There are lots of possible starting points because a starting point is any filled in dot, and there are lots of filled in dots. But just to show you, here there is no h and no k. So remember that h is what is subtracted from the x and k is what's added or subtracted outside of the greatest integer function bracket. So in this case, there's nothing subtracted from the x inside or added. There's nothing added or subtracted outside. So h and k are both 0. And what that means is that we'll have a filled in dot at 0, 0. And in this case, my a value determines the step height. My b value determines the step length. This is what it looks like. And we had seen a basic version of the step function in another video. But just to show you what would happen if I did have an h and a k value. In this case, my h value is 2 and my k value is 1 because there's a fixed negative. What that means is that I'll have a filled in dot at 2 and 1. So at the point 2, 1, I'd have a filled in dot. And the rest of my function continues from there. So the impact of the hk is that at hk, I will always have a filled in dot. I'll continue the rest of my function from there. This is just pointing out that these steps continue towards the right and the left, up and down. Keep going. So because these steps continue and because there are lots and lots of steps, it means that there's more than one potential quote-unquote starting point. Like here, it says that my hk is 2 and 1, but any filled-in dot could have been a starting point of this same graph. So there are lots of other ones. If you want to pause the video and try to read out a couple of them, you can. Just to think them out. Now's a good time to pause because I'll show the answer in just a second. But here are some examples of other possible starting points. All of these guys are potential starting points, and others too. So it means that I could have written this same function this way with a starting point of 3, 2, or a starting point of 4, 3. I could have had a starting point of 1, 0. And there are lots of others too. So as opposed to some other functions, working with the greatest integer function, there is more than one rule that gives the same graph. That's a little bit about h and k and what they mean. Next, to show you what the a value does, so compared to the standard step function, if I have a 2 in front, notice that the vertical distance between the steps becomes 2. If my number outside was 0.5, notice that what happens is that the vertical distance between the steps is only 0.5. And if I had a negative a value, notice that as opposed to these 3, in this case, the steps are decreasing. There's a little bit more to that story, but we'll talk about that in just a minute. So a affects the vertical distance between the steps, and it has some impact on if the steps increase or decrease. But what we say is that the actual distance, the vertical distance between the steps, is the absolute value of a. The distance between the steps is the numerical value of a, but it doesn't matter if it's positive or negative. So in this case, where I had a negative 1, it really meant that the distance between the steps was 1. So we'll talk about what that negative means in just a minute again. The b value, notice that in here my b value is 1, and in here my b value is 2. Notice that the steps are half as big. In fact, the step length here is 1 over 2. And here when my b value is 0.5, my step length is 2. So b affects the step length, and more specifically, it's 1 divided by the absolute value of b. That is the step length. If the b value is negative, is the difference between the steps opening towards the right and the step opening toward the left. So you'll also notice that here the b is negative, and here the steps increase, and here they decrease. So b actually has 2 impacts. And the increasing or decreasing is based on both a and b. So actually what we say is that if the product of A and B is positive, in this case they're both positive, so their product is positive, the steps increase. And if the product of A and B is negative, meaning if one of them is negative, the steps decrease. So in both of these cases, I had a positive B, and I know that because the step opens to the right. And in this case, I have a negative B because the step opens to the left. But this downward slope means that the product of A and B is negative. And I know from the step that B is negative, so it meant that A would have to be positive there. And in this case, if both A and B are negative, B being negative means the step opens to the left, but it means that the steps will increase from left to right. And I'll show you quickly an example, just one, of how you would graph something like this. So I would go through these sort of parameter by parameter to figure out some important stuff. The distance between steps, meaning the vertical distance between steps, is based on the A value. And in this case, the absolute value of 2 is just 2. That's my vertical distance. I also know that the length of the segment is going to be 1 over the absolute value of B. And in this case, that's 1 over 3, which is 3. My starting point is the H and K. In this case, it's 1 and 1. Because my B is positive, means that my open circle is on the right. It's going to be filled in on the left and open on the right. And the product of A and B, because these are both positive, means that my steps are going to increase. They're going to go upwards to the right. So where do I begin? Well, I'll start by drawing a filled in dot at 1, 1. And I know that my step length is 3, and I know that my step opens to the right. So I can draw the whole first step. And to draw the next steps, because I know that the direction is upwards as I go to the right, this is going to be the trend of the steps. And the distance between the steps is 2. So I'll skip 2. Put in my next step, and I can go backwards as well. It doesn't matter where I draw the others. And what I should probably also do is include a scale on my axes, and that is how you graph a greatest integer function.